All right, so let's get started. Thank you so much for being here with this panel. We have 5 of our keynote speakers together. As you already know, they cover a wide range of expertise. So what I will start with is just repeat the information, who they are, but I also want to have Kyle and Brad say a little bit more about their work because their keynotes are this afternoon. So we have Andy Connolly from University of Washington, Betsey Stevenson here at University of Michigan, and Ashley Llorens from Microsoft. And Kyle Cranmer is professor of physics and the director of the Data Science Institute at University of Wisconsin. I don't want to say a whole lot because I know our session chair this afternoon prepared a really good introduction about Kyle. So, but Kyle, do you want to just say a few things about yourself?
Sure. Hi, everyone. Sorry I wasn't able to join you yesterday. We had a big event at UW-Madison related to AI and data science and things like that. So my background is in particle physics. I worked at the Large Hadron Collider on the ATLAS experiment, still do. Around 2012 is when we were involved in discovering the Higgs boson. That was pretty exciting. Shortly after that, with Andy and others, is when we had this investment from the Moore and Sloan Foundations to start a data science environment that started the NYU Center for Data Science when I was there. So I was at NYU for quite a few years, and around that time I pivoted to thinking a lot about how to use deep learning primarily in the physical sciences, and then moved to UW-Madison a few years ago to be the director of the Data Science Institute there, and these days that's a campus-wide effort, so that goes all the way from agriculture to health to education to the physical sciences, etc. And yeah, so that's roughly my background.
Okay, so I want to say one thing about Kyle, which is he has an H index of 237. When I told some of my friends here, they're like, whoa, that's crazy. How is that possible?
Well, big science, yeah.
So Brad Malin from Vanderbilt University, I also don't want to say a whole lot and leave that to the session chair this afternoon, but Brad, please say a few words about your work.
Sure. So I'm Brad Malin. How do I summarize this? So I'm at Vanderbilt. There's 2 different sides to the house. There's the university and there's the medical center. I kind of straddle both sides. But I helped start the Data Science Institute at Vanderbilt, where we actually toured some of the other data science institutes. So we stole all of your methods. I appreciate it. So I guess historically, just so I have some intuition. So I actually was one of the first graduates from what became the machine learning department at Carnegie Mellon. And so I have always started focusing on aspects that are at the intersection of machine learning, biology, and just society more generally. And so I ended up going to Vanderbilt because they wanted to start a machine learning program that was focused on all the electronic medical records data that were stored there. And so I thought they were lying, and I said, show me what you can do. And they said, yeah, here's like a $30 million investment. Go see if you can make this work. And so we did that. And so over time, we've kind of built up a large relationship between the School of Engineering and the School of Medicine to try to figure out how best to cross-train people so that students have an understanding of domain expertise, both in the clinical domain, but also in the biological domain, as well as how you actually engineer these systems into scalable machine learning environments. I think what a lot of people know me for, though, is I do a lot of work on privacy and security associated with a lot of these systems. And so I'll talk a little bit about how to break them and scare everybody later.
The one thing I want to say about Brad is after we told our faculty members that we invited Brad as our keynote and he agreed to come, one faculty member here who's a great researcher in data science and AI and healthcare ethics said, wow, you got Brad Malin? He's my role model. So I'm very happy that you're here.
That's great.
I want to remind everyone, please enter your questions through a Pigeonhole. You can start now, and if anyone who's not aware, there is a QR code on your table that you can use. I'm going to ask several questions to start things off, and then we'll go to audience questions. You can either enter them through Pigeonhole, or you can stand over there and we'll do and ask the question in person. So I want to start out asking the five of you about the expanding scale of science. So astronomy and quantum physics are probably sort of the two best examples of big science, but also industry research, the scale is getting bigger and bigger. Healthcare research scale is getting bigger and bigger. So what is AI increasing the scale of science overall? And what should academic researchers and institutions do in any way that's different? And that can be anything. For example, research infrastructure, reward mechanism, what a research lab will look like, how we train students, and so forth.
Okay, I'll say, well, particle physics is definitely, the Atlas experiment has 3,000-4,000 people on it, and we write, every paper has every author. So that crazy H-index has a lot to do with that. I hopefully contributed to a few of those, so I don't feel too bad. But I think I'll talk about some of the positives are clear that allows you to tackle really big problems, right? And you're only going to do that in collaborations and et cetera. That there are a number of downsides. One of them is, there's an issue of transparency when those collaborations put something out, and this is also true of like large industrial efforts or things like that. When you see a lot of authors there, everyone's kind of agreeing to it, so a lot of the discussions happened inside of that collaboration. So it's almost like a mini peer review that happens that's not necessarily exposed to the outside. And then that also means that you're seeing some kind of polished thing at the end, and you're not exposing a lot of what's going on. In astronomy, where you do have big collaborations, it's usually structured quite differently, and there's a lot more opportunity for individual groups to try things, to have kind of disagreeing conclusions on the same data set. I think that's generally more healthy. Those same kinds of issues are relevant for things like tenure and promotion, like when you're looking at someone and you're like, should you hire them? And they're one of 3,000 names on a paper, you don't know what they did, and that's a problem. So I think that on one sense we want to embrace big science and big collaborations, but there are some things at the level of how we publish and how the kind of atomic contributions and making it clear what the roles and responsibilities and contributions of everyone are that require really big kind of change in terms of norms and expectations. And I think those things are really important, and somehow we have to advocate for them. And I think if you look at what's going on, for instance, like NeurIPS and the big machine learning conferences right now, that's kind of breaking right now. It's like, and so I think the idea of having more atomic contributions, but it's a really social change about how we think about doing the science at that scale, and somehow we have to contribute to that change or it's not going to happen.
Thank you. I think one of the questions I think about is how much AI is actually driving the big science, and I think we have to recognize that the timescales are very different in terms of the development of AI compared to these big experiments. If you look at the Rubin Observatory, it was 25 years from the design or conception through to operations. The next generation of space telescopes like Habitable Worlds are also going to be on that sort of timescale. LHC, the next version of LHC is 20, 30 years in terms of the construction. And so the technology refresh underneath it is enormous. And this means that AI doesn't get integrated into the design of the actual experiments when they're being put in place. And I think this is a challenge for us in terms of researchers, in particular working with these big experiments, because we need to have a quicker refresh rate. And so I think where AI is actually having the big impact is working with the data, is making us quicker in terms of how we're getting the results out. And the next stage is going to be the constraints and the correlations that we're finding in the data we're going to be able to tease those out better with these new methods. But I think the really exciting part occurs when we can start doing experimental design with AI. So now that we can maybe accelerate the next generation of experiments. So maybe it isn't that we still need to build the big telescopes, the big colliders, because they are what drives our ability to make these big discoveries is hitting the next energy frontier, or opening up a new set of wavelengths, or a new way of observing the universe. And I think this is true across whether it's biology, whether it's physics, whether it's astrophysics. But I think if we can start thinking about using AI to do experimental design to ask some of the smaller questions, but to be able to build those experiments more rapidly, so we have a much more rapid turnover in the science that we can do. And I think that will be really exciting, and that will be something that will potentially change the way that we're doing some of the big science in physics and astrophysics.
Well, you know, I find it inspiring just to listen to you all and the questions that you're curious about, the frontiers that you push on. And for me, it reaffirms the importance of academic research for that purpose, to just the sheer intellectual diversity of how, as a society, we push on the frontiers, and also not necessarily having those pursuits align with things that the market solves for. Like that's, you know, industrial research is very good at solving for problems that are important to the market and align with you know, the company's direction. And probably the things that you're pushing on will eventually do that, but on a longer time scale. So I think it's really important. The LHC, the Large Hadron Collider, I think is a good illustration of that. Right? But also, I think, a good illustration of maybe one aspect of scale and the importance of research infrastructure to support research that happens at that scale. And I think there are other concepts of scale as well, and especially scale of data and compute needed to push forward the frontiers as research becomes increasingly, I'll use the phrase, AI native. And so one of the things that I think about and we think about at Microsoft is, you know, what is the important research infrastructure, the enabling research infrastructure in the AI native era, where we need scale of data and compute to solve some of those problems. And that's one of the reasons why, as a company, we supported the National AI Research Resource, if you're familiar with that initiative coming out of the White House and the National Science Foundation. So at the very least, getting that compute infrastructure, so that becomes something that can be more of an enabler. The most recent thing we're doing with NSF is more focused on scientific discovery in particular, and adding platforms to that mix. So there's a notion of scale of compute, scale of data, and how we accomplish data sharing. But then all the platform technologies that also become enablers. Microsoft has a platform for discovery we call Microsoft Discovery Platform, and it's really applying models and agentic tools across every phase of the life cycle, from the initial research to the hypothesis formation, and looking a little bit forward, even the idea of connecting that to self-driving labs. And so again, just thinking about that research infrastructure that supports research at scale in the AI native sense of big compute, bigger data, again, applied to these problems that academia is uniquely situated to pursue.
So as the economist and social scientist on the panel, I was just going to tie this back to what I was saying yesterday about how, you know, it took a long time for the factory floor to get reorganized to take advantage of electricity. And so, you know, it will take a while for companies and for scientists to get reorganized to take full advantage of AI. And, you know, I sit on the board of a company, and what I've said is we should think about how would we have built this company from the ground up if we were building it in the world of AI. But that doesn't mean the trade-offs are such that we should tear the whole company down and rebuild it from the ground up to be working with AI. And I think the same thing's true with science. Like, there there are investments that have been made that now the marginal contribution to get those investments to reap rewards is pretty small, and so you want to keep doing that. Even if you had had AI 20 years ago, you would have built the whole thing differently. And I think that's the transformation we're going to be facing, and there's a lot of things that it does just make sense for it to play out over a longer period of time, because there are, it's not worth tearing something down that currently exists to get the advantages of AI. But anything you're building new going forward, you do want to say, how should I do this differently? And I think whether we're talking at the level of individual companies or scientists, like everybody's sort of going through that process right now.
I'll just say that last point, I completely agree, and I think it's interesting because that marginal cost and would you have done it differently also applies to all of the incentive structures and all the social pieces that we do about how we operate, and that's kind of what I was speaking to at the beginning, but it's also true, like maybe you would do it totally differently now, but getting from where we are is like a very non-trivial thing. So.
Exactly. Oh.
Sorry.
Imagine if you just had that mic at the beginning of the panel, what would you have done?
Okay, there are lots of questions from the audience, so I'm gonna set my questions aside and start from some of the audience questions. So first one, if the AI bubble bursts and some big companies go under, what are the implications for the use of AI in science and research?
So I work with a lot of those companies. It will burst. What exactly will be left over is unclear. I will say that there's two parts to that equation. So one is what happens if you end up with a catastrophic failure of the entire infrastructure right now. I think that it would be a situation in which what we're seeing is that we're going to rebuild it in a non-commercial setting, and we'll probably end up doing it in a manner that ends up being cheaper. I actually have like a major concern currently about how much it costs to use a lot of the AI infrastructure that exists out within companies. I can, as probably some of you might be able to attest to, you might not be able to attest to, but I have definitely had multiple graduate students and postdocs who have blitzed through $20,000 in the course of a weekend when trying to work with these systems, because they train and they go, no, that's not right. And then they train it again, and then they train it again, and then they train it again. And then eventually they get one that works for them. And they're like, woohoo, I got a success. And I'm like, yeah, cool. Can you pay me back? And so I actually think that the current infrastructure is broken, to be honest with you. I think things are getting to be way more expensive than they need to be. I think we're also having way too much reliance on a lot of corporate endeavors. That said, I do think that what we're seeing is that we're learning that some of we're figuring out that some of these extremely large models that we're starting to work with are unnecessary, and that we're starting to build them smaller and more focused, and that's what you're starting to see with some of the more agentic strategies that have the ability to distribute it and make it cheaper. It may take us off of this critical infrastructure that we're starting to see that's living outside of some of our academic domains.
So I just want to jump in on this. As an economist, I want to talk about cost, because I think that the whole system is mispriced right now. If you think about things like environmental costs, resource use. So when economists talk about costs, we want to think about like opportunity costs. Are these resources that we're using, like what would their value be if they were being used somewhere else, right? That's sort of like the underlying true cost. And I think the whole system is mispriced, in some ways underpriced, and maybe some ways overpriced. It's just not really well priced. So there's that issue, is are we pricing it correctly? But then you brought up something else. Could we do the same thing with less resource intensive models? And that's about like really getting the true underlying costs, the resources we're using down. And I think there's a natural way in which market pressures will push those true underlying costs down. But then there are these big questions that exist around what should be in the public domain, what should be in the commons, how do we divide things up that have large fixed costs and very small, variable costs. And I think those are all things we're still trying to figure out.
Yeah, it is interesting, the perspective of the entire system and how we price in externalities at the level of the entire economy. Hopefully we get better at that over time. I do remember the initial release and the pre-release of GPT-4. And again, it was the largest scale model of its kind. It was a real step function between ChatGPT 3.5 and 4. And it was kind of an existential moment for the research community at Microsoft Research. And there was a real question as to whether there would just be this big model and the next model, and then the community could just go on to something else. Maybe we didn't need to make models anymore. How much machine learning research still needed to be done? My sense at the time is that the technology progresses at the level of the ecosystem, and there's a natural diversification. And so the advent of small and medium-sized models, I think, has been critically important. One, as research infrastructure to enable more exploration by more folks, but also for the point you're making that it actually is it's an efficiency vector in terms of getting, how much intelligence can we get in a smaller package. And our efforts on the Phi series have focused on that. Some of the more specialized models that distill, so you amortize the compute of the large models by distilling it in a focused way into the small models, and then the agents can hit those small models much more in the agentic systems. So I do think the advent and the progression and the advancement of small and medium-sized models are important for all the reasons that you mentioned. And also, just to echo your point, we as a company and our peer companies, we have a strong market incentive to continue to push the efficiency of these things. We have a strong incentive. Our customers, want cheaper inference per token. And in fact, if you look at the cost per token, of GPT-4 when it was first released versus GPT-4o and some of the successor models, there's definitely been an upward trend, downward trend in the price and upward trend in the efficiency. But, again, the market pressures, I think, will continue to exercise us that way.
Yeah, it's a whole complicated thing. We're talking a lot about the original question was less on the economics part, but the economics part is certainly important. I guess one thing that I see that's is that the kind of scaling narrative that that you're going to make progress by making ever bigger models and huge amounts of data. There is, we've seen this amazing transformation, and there's some kind of empirical evidence to that side. At the same time, it's also a very good tool to try to block everybody out, so that very few players can really be playing in that space. And so, that's one of the lessons of something like DeepSeek, is that you think a little bit harder, maybe there's a much more efficient way to do it. So on one side, it certainly makes sense for a company to try to reduce their operating costs to be more efficient. At the same time, many companies are basically happy to lose a ton of money right now because they're trying to corner the market and shape regulation and all sorts of things that are wildly far away from any kind of efficient market. I'm not an economist, but so I think that those kinds of pressures are driving a lot about how we approach all of these things, how we think about it. And so I think at the level of academia, you see that, when we're doing hiring for big initiatives, we have a big AI hiring initiative at UW. Many people are thinking, oh, this person's doing AI. They need to be training some gargantuan foundation model, and everyone needs resources at that scale, and that's just not true. Not only can you make more efficient ones, many of the things that people want to do just don't require those kind of models. The other thing is that to the extent that those are opportunities and we want to leverage them, academia usually doesn't have the engineering skill set to do that or the capacity to do it. So right now, ideally, we have some kind of good partnerships with industry that does have that kind of capacity. But if things change dramatically, then what happens, right? We will be kind of left in the lurch, and maybe a lot of those people will get hired in academia again. But academia needs to be thinking about, like, how do we make sure that we have some kind of essential engineering capability, I think, and still work with industry right now, but somehow be protected against the potential downfall or something.
I actually think there's a huge benefit of engaging with academia in this space. I think one of the real strengths of universities is the breadth of the research that is ongoing from arts and humanities, social sciences, through the sciences of engineering. And so there's a lot of opportunities for working on how do you compress the data that's going into these models? How do you devise more energy efficient approaches to training models? And I think it's part of the benefit of the university is because it's so diverse, you can bring many different perspectives into that, and you can begin to explore this space without having the drive that is the way that you're successful today is by building a bigger data center or having more GPUs, which is one of the, even if you're trying to make these as efficient as possible from the cost perspective, is still the way that you can be more successful is by just having more infrastructure. And I think this is where we get to play a role in partnership with the companies in defining and designing these more efficient ways of actually working with the data, whether it's with smaller models, whether it's more efficient ways of actually training data sets or building out different architectures. And so I think there's a great place for us in terms of developing this work. And then one of the jokes that my postdoc advisor used to say is there were two entities that didn't change and had lasted forever, and they were the Catholic Church and the universities. And I think the slow growth and change at universities is actually a benefit. So if the bubble does burst, then we have been doing research for the last hundreds of years, and we'll continue to do research in that space. And so I think the fact that science often and engineering often moves incrementally and then occasionally has these large paradigm shifts is kind of one of the protecting factors in terms of doing our research.
Okay, so the next question, which is the question that got the most votes is, well, aside from the market and what we just talked about, what worries you most about AI? And how do we effectively communicate that worry to impact policy change and regulation?
I'll take it. This is an easy one for me. So the thing that worries me most has to do with the relationship between the technology and humanity, and the ability for the technology to influence the way that people are thinking. I think that it has the potential to totally augment the way that we do things, as well as allow us to make connections that we might not have recognized otherwise. I also think that, like many other types of technologies that come along, it has the potential to completely destroy the way that we think, to the point where it's almost mind-numbing. And I think that as an example, and some people who I was talking to last night heard me say this, there was like this absolutely astounding paper that came out of Poland a couple of weeks ago that was looking at the ability for endoscopists to perform their job, where they're putting the endoscope down somebody's throat and checking to see if an individual has an adenoma, right? And so then they checked to see how good they were doing it before they gave them the technology, and they had like an AI decision tool that was built into this, right? And so then they let them use it for 6 months, and then they turned it off, and they checked to see how well people could actually detect adenoma. And then you would say, okay, well, that's probably going to fall back to like their normal level. And instead, they saw that on average, it fell way below their normal level, okay? And so this is what's become known now as the de-skilling paper, okay? And so, there's a question about, are the skills that you currently have necessary? And how do you make sure that if they are, how does somebody maintain those skills while still working with the technology. And I think that this is going to become one of the most foundational challenges when trying to figure out how to build this technology and integrate this technology into ways that don't end up destroying the way that allows us to either do our work or continue to be creative, such that we don't become completely reliant upon it. Now, this is not just an AI issue. This is true of like many new types of technologies. You could say the same thing about like the introduction of like really, really, really simple technologies. Like if you're a doctor and you learn to use a stethoscope, that's different than like using like a little horn where you're like trying to figure out if somebody can breathe. And so it's like, okay, well, what happens if I take away the stethoscope? I'll pause there. I'm just going to say that I think that this whole notion of like human AI teaming is going to be one of the most critical challenges that we run into.
Yeah. Well, since we've got society in the name of this whole thing, I'll say that I think probably the thing that I'm the most worried about is is just thinking about how humans, society transmits information, and going back, forever ago, it was storytelling and et cetera. And then at some point you had like the printing press and that rapidly accelerated the speed at which you could transfer information. And then, with the internet, that also changed things dramatically, but you still had people writing articles and blog posts and things like that. Then you had, later like Google and maybe Wikipedia or something, and that allowed you to find that information much faster, but the set of sources was still quite distributed. You still had people writing. But once you move to a picture where now some big LLM has, consumed the internet, and now when you ask a question, you start getting kind of the AI response on Google or whatever platform it is. You have kind of a central source that is providing the information that you're searching for, which seems from a user interface point of view very similar to Google. You ask a question, you get back an answer. But before, you pointed to a diverse distributed set of sources, and now you're pointing to a centralized set of sources. So if someone wants to intervene on what the answer to a question is, you have like a single point of intervention. So as a concrete example, without trying to be too political, I grew up learning that the Statue of Liberty stood for all sorts of things about the United States and immigrants and things like that. And a couple years ago, people started saying, "Oh no, that's not what that means. That's not, the Statue of Liberty never stood for immigrants, and immigration and things like that." Of course, you could just Google it and you see, well, no, that's obviously not true, because here's like 5,000 examples of people saying the opposite. But now if suddenly one day you ask that question and it's going through a big LLM, AI generated answer, and someone can say they don't like that answer anymore, that's a coordinated, correlated intervention on how we communicate as a society at a level that's never happened before. And it's very different than just the speed of communication. And so that's probably, to me, like probably the scariest thing.
Maybe I'll admit or confess to being net optimistic about this whole thing. But, I think that in a sober way, every new generation of technologies has opportunities and risks. And the fundamental pursuit is maximize the opportunities, mitigate the risks. And so this is no different in that sense. I think that, there are important considerations. And maybe there's different ways to kind of sketch the space here, but at the level of individuals, at the level of organizations and institutions, and then at the level of the broader society. And so individually, I do think a lot about how we accomplish effective human-machine teaming with increasingly intelligent agents that can act with greater autonomy. And to make sure, to ensure that as we're advancing the capabilities of the agents, that we're advancing the sophistication of the interfaces, and essentially what enables the agents to. I mean, the AI agents, their agency is derived from human agency, and their agency is granted to them by the user. So what is that fluid, kind of collaboration and oversight at the level of the individual? And of course, skill atrophy is something to think about, and where we come to rely on these technologies. I think there are a number of things where, if you just took away my cell phone, I'd be screwed on a number of levels. So yeah, where is that? At the level of institutions, I worry that, I worry about the inertia that we have at the institutional level, and that can go from organizations like companies to to policy making, and if we can effectively co-evolve institutions with the technology, and specifically going back to the individual, the way individuals are taking upon themselves to use the technology. I mean, we know that ChatGPT reached 100 million daily active users more quickly than any other technology ever. And so people are going out and getting the technology, they're using it, and they're doing it regardless of what's happening inside of their companies or their organizations. And so can the institutions evolve with the patterns of use? And then again, the policies associated with those as well. At the level of society, I mentioned this in my keynote, but I think a lot about the equitable diffusion of the technologies and the extent to which advancements in AI matriculate into the most useful tools for the most people, regardless. I mean, we'll be in a good situation if, you can roll the dice and randomly be born to any family anywhere and have the same opportunity, education, health, but also literacy, fluency, and access to technologies and the best tools. So I think there's plenty to be optimistic about in that spectrum. I think there's plenty to worry about, and to the extent that it really directs our focus and investment to assuring that we maximize the opportunities and mitigate the risks.
So I actually want to agree with all three of you and say I do tend to come at this whole thing from a more optimistic space, because if I look at technology, throughout human history, the reason we have the living standards we have today is because of technology. This point that we're going to lose some skills and we should think purposely about them, I just really want to double down and emphasize, because we will lose some skills, and the question is, do we need them? And I'll give you an example. I once, when I was in my 20s, traveled to a very remote village where I had to do my laundry in the river on a rock like everybody else. And as I was trying to do my laundry as a 20-something American on a rock in the river, a group of children laughed and laughed at me because I was no good at doing my laundry on a rock. And finally, a 9-year-old girl came over and said, "Could I do your laundry for you? You need some help." And so I learned to use a washing machine. I don't have the skills that people needed before they had a washing machine. There are lots of skills we're going to lose, and the question is, which ones do we need, and are there better ways to keep them up? And I think we tend to have a habit to be very nostalgic about the past. I've studied marriage for most of my career, and boy, the nostalgia about the past of marriage is something. Like, people long for some time in the past because they only remember the good parts and they forget all of the bad parts. And I completely agree with this idea. New technology brings opportunities and risks, and our job is to focus on how do we make the most of the opportunities? And that actually requires seeing the problems of the past. So we can't romanticize the past if we want to actually take advantage of the opportunities in the future. And I just think that's a really profound thing. Now, there is something that does actually scare me, and none of you mentioned it, which is what happens when I should say one more thing that gives me like a lot of hope and optimism. And it's sort of building off something I said yesterday. We're sitting around, almost everybody in this room, I bet, has an IQ that is at least a standard deviation above the median. And we're like, yeah, this is a great way to live. Well, guess what? The majority of the population's living without that, and they're pretty excited to have a technology partner that's going to boost their cognitive ability. And we've been taking for granted this idea that the richest people in society should be the ones that were blessed to be born with the highest IQs. And maybe that's not the right notion of fairness. Maybe AI is going to give us a different notion of fairness where no matter what kind of IQ you're blessed with, you have the opportunity to build a good life. So that's part of where my optimism comes from. But it's also part of where my fear comes from, which is what happens when we actually can't understand the technology. Like the technology is so advanced, it's actually beyond our capacity to understand it. And does that make us in some ways subservient to it? And you know, I think there's a whole bunch of people who know more than me that debate this back and forth, but I do become fearful of things where there will be only a very small number of people in the population who can actually understand what's going on, and how that might change political power, which gets back to the point you made about how we start to shape the information people have.
So I agree with everything that's been said. And I want to triple down on the skills aspect, right? Because I think it's really important. I think what I worry about is we don't really know how we should be educating students today so that they can be successful in the next 10, 20, 30 years. Whether pedagogy is going to change as we adopt some of these new tools, whether it's going to improve our ability to learn and retain information, or whether we're going to get this, as people have talked about this, this assumption that having confidence in someone telling you something is the same thing as understanding what they're telling you. And I think that's a real challenge across whether it's at the research or whether it's just kind of at the research and science level, or whether that's just in society, that we believe we understand it if someone says something confidently and clearly to us, even if it's not correct. And so what I worry about is I don't know how we should best be teaching the skills that we're going to need, but I do know that if we don't do it right, it has a 20+ year impact on the people who we're actually going to be training today. And so trying to understand what is the underlying structure, what is the grammar, what is the foundational knowledge that you need to have so that you can develop and continue to be a curious, inquisitive person who is also is agile enough to be able to think through the changes in technology and be able to continue to learn over the next 10, 20 years or 30 years throughout your career. I think developing those skills and also developing the ability so that people know how to interact with the technology is not something that is clear to me. And I think that's something that we need to also be studying in a lot of detail and evaluating the ways that we're teaching today and the ways that we're proposing to teach today. Because often when I look at our university, it's very ad hoc. Someone's interested in integrating AI into their technology, into the way they're teaching, and they're just doing it on their own. And I think there needs to be a more thoughtful approach to this.
Okay, so before I ask the next question, I just want to tell the audience members that feel free to, we will be able to answer only a very few questions of all the questions that you asked, but it's not a waste of time because at Midas and broadly at the university, a lot of the AI support organizations are trying to understand people's worries and trying to understand how people see this as an opportunity, what kind of support you all need. So the questions that you asked today and the questions you asked yesterday to the leadership panel, these will all be very useful information to guide our work. So feel free to keep asking questions even if they don't get answered on the spot today. And feel free to email us more questions and more of your thoughts. So with this, I want to ask the next question, which is a topic we really did not touch at all yesterday or probably today in the presentations too, but it's something that is very interesting. At what point could you conceive of AI being moral, having moral responsibility? What about moral standing? So that, in a larger picture, this is a lot of people talk about how we think about AI, morality, responsibility, and even personhood. And regardless of we think that, how do we do our best to ensure that AI has a positive moral impact on the world?
Well, I'll start because I think I'm going to think about this from a very mechanical point of view, but the first question is like, how do we assign liability to AI? And, you know, a lot of economists have realized that a lot of this is just the same problems we've already been wrestling with, like principal agent problem. So if you took economics, you learned about the principal agent problem, and agentic AI, just an agent. And so the ways we think about how agents might misbehave based on what their principles might do, that applies in this scenario as well. And so, you know, you want to think about how we start to, so this, my first thing is like moral expectations for what the AI should do is we need to know who's responsible for the AI's behavior, right? In the same way, we might think about who's responsible for a child's behavior, right? If a child harms somebody when they're 7, is the child the moral agent or is the parent the moral agent, right? And that's something we've wrestled with. That I think another way we need to start thinking about it, you know, from a AI perspective is personally think the moral agent has to be the user, and somebody has to take responsibility because the AI becomes very dangerous if we say, no, you know, it's the AI that's going to be the moral agent that's responsible. I think that there is this other question, which I wasn't sure this is where you're sort of going, which is at what point is AI itself a moral creature that we have to start to like assign rights to? And my personal view is like we're quite far from that, and that, you know, humans have a great desire to assign, to anthropomorphize all sorts of things. And I think it's important to realize that, you know, AI is not a creature. You know, if we want to start moving towards our moral responsibility towards other creatures, we could change our policies about how we treat other life forms like animals before we move into thinking about treating AI like a life form.
Yeah, you know, I mean, I agree with a lot of the points about the kind of legal frameworks, and a lot of these, and these are not new questions. I mean, one thing that has come up many times is that when we talk about AI in society, like a lot of times it's sort of a mystery. A lot of people don't know what it is, and so there's some mysticism there, and it seems like these are like somehow fundamentally different questions because AI is being used, and you know, in many cases you can replace the word with, you know, something that's being automated or you know, and so like issues of liability and those kinds of situations. So many of the same things come up. I guess one part that we also have to be careful of is that people somehow, like, you know, this algorithm's deciding if you should be paroled or not is not biased because it's just an algorithm. Like, you also have to be careful that people are offloading some kind of what a person is doing onto some algorithm and then saying, oh, it doesn't have any, like, it's you know, there's no morality issue or something. So we have to be careful with those kinds of issues. But I don't know. I also agree that we're pretty far down the road. I've also heard in the public sphere people, what I'd say maybe overly simplistic takes of like, oh, we're building this technology so we can control all of the things. I think there's going to be a lot of emergent behaviors that are unexpected and you know, that will have consequences that are the people that are designing it don't know what those are ahead of time. So we have to be careful. So, yeah.
Maybe I'll just contribute by adding complexity to the question. Because, you know, I think, you know, moral reasoning happens over and with respect to some value system. And, you know, I think as we try to automate this kind of reasoning, we realize how complex how complex of a pursuit that really is. You know, there are values at the level of, again, societies. There's values at the level of institutions. You know, at Microsoft, we may have to make some choices about what kinds of guardrails we'll put on systems that would contain, you know, what the system is capable of doing for any particular user. And then there's what that user values. And all those value systems, I think, are at play with respect to how the user uses the technology. And by the way, that's also contextual depending on your societal context. So when we think about gender bias, for example, that means something different here in this Western context than for my colleagues in our Bangalore, India lab. Gender bias means something different. And so one of the things we're focused on is trying to understand how to characterize these value systems in a way that can be represented contextually for an AI system and correctly influence its ability to do decision making. In fact, my colleagues in our Beijing lab have come up with this technology where you can take a quick quiz and then it infers something about your value system and then tries to align the decisions and generations of the agent with what it infers your value system is. So I think all I've done is make the question more complex, but that is something we're thinking about and putting some investment in now.
I was going to just tie two things together in this point, which is humans in most societies, definitely Western societies, really dislike when technology harms somebody relative to a human harming somebody for reasons I don't really understand. It's just sort of whatever their moral framework is. If Waymo runs you over, it's way worse than if a human driver runs you over. So I don't know if any of you saw like the New York Times article that had in like paragraph 33, oh yeah, Waymos have 91% fewer accidents. But the whole article was everybody's afraid to go into a Waymo. And so they don't, until the very end of the article, do they say, oh, by the way, but it is actually safer. And I think there's a question of who's responsible. And then also, is it okay to have different value systems? Like, is it okay to say that it's worse? It might be more random for if a judge decides you get parole, and maybe less fair in some technical sense, but at least it feels like a person decided. Is that a value system we want to adopt, or do we want to get people used to the idea that actually a very, an algorithm will lead to a very, very, fair outcome, but then there's still do they require some human behind it to have verified it? And is the question that they don't like they don't like the decision being made by a machine, or they don't like it when they don't have an outlet with a human to complain to when they don't about the machine? And I tend to think it's the latter, but these are all really big questions that I think everybody's wrestling with right now.
Without going on for a long time, just two kind of semi-technical things that I think are pretty interesting is, especially in like a lot of legal frameworks, this idea of kind of counterfactuals is very important, like what would have happened if you would have done something different. And I think that points to these discussions about both interpretability and AI, kind of black box AI systems versus more mechanistic type approaches. And so, from the scientific point of view, I like causal.
By that. So imagine you have 2,000 investigations across the globe on how a particular drug has fared with various populations. And you have like all sorts of various types of conflicting evidence. Now, imagine that some of those journals are non-reputable, okay? And so you end up with taking all of these studies of evidence, and the AI now has to try to figure out which does it include, which does it not include, does it weight them, how does it communicate the weighting back to the end user if it's going to communicate it at all. And this problem is actually only just going to get worse because, as we've said, the modern AI is driven by data, right? Where a lot of what we're doing is really just machine learning, which is a very special case of AI. And so as a result, what's going to end up happening is that we're going to say we need more data. We're going to generate more things. And then we're going to have challenges on trying to determine the veracity of these things as well. And then trying to determine if the AI is capable of recognizing when something lacks veracity. And I think I'm not always a negative person, I swear to God. But these are the types of things that we're wrestling with because we're basically being asked to make recommendations to the NIH on how should they fund these types of systematic reviews because they're necessary, because no single study is actually sufficient to determine whether or not a particular intervention is worthwhile. And so that's one of the major challenges I think that we're going to be running into.
So maybe I'll take it in a slightly different direction, and I'll try and end positive at the end of it as well. We talk about equity in terms of access to the tools that we have, but we also, I think we have to recognize that there's an imbalance in the research community in terms of their access and ability to work with AI when it's appropriate for their fields, and sometimes it isn't appropriate for their fields. And so when I look at the communities who I work with, then I find there's a small subset who are all into AI, have a deep understanding of how it works and how to integrate it within their workflow. And then there's the rest, a large fraction, which is larger than the small people who are all into AI, who are trying to understand how do they engage with it in terms of their research. And it's hard to say to someone, go and use ChatGPT to teach you how to use AI in your science, or go and find a tutorial on the web and use that to do it, because they're just not very good. And so I think we're building a gap where unless we can start bringing in people who can actually train and educate our current researchers, there's 15,000 researchers at the University of Washington, all who have deep skills in different areas of research. And we don't really have the capacity at the moment to enable them to learn the skills that they need for their research. And I think that's an area and an opportunity for us as universities, and particularly thinking about us as data science and AI institutes, and thinking how we can actually bring in the people to help educate. And that education has to occur at many different levels, from the basic introduction to AI, but that's not enough. You have to go to how do I make it so that you are effective in understanding AI, and then using AI, and then adapting AI to your science or your engineering or your arts and humanities projects. And that whole training aspect is something that I think we're not staffed to do that. And I think it's something that we need to start addressing pretty rapidly. And if we can do that, I think that's when we start benefiting, the whole of the research community begins to benefit.
Can I actually ask you a quick follow-on question? Because I'm genuinely curious. So if you think about a piece, a tool for research, like an electron microscope, clearly you're going to have to educate me in the use of an electron microscope. I don't have one at home. I can't pick one up at Walmart. On the other hand, there's something ubiquitous like the internet. I don't really need you to train me to use the internet. I'm sort of bringing that, and maybe some skills I picked up along the way. And then there's language models. And I just wonder how much you see that as a kind of top-down endeavor, training people to use that, versus what you're expecting is happening organically. And what are you seeing in your classrooms?
So I think that's a great question. Language models when I look at physicists and biologists, a lot of the time they're not using language models to do their science, right? They're working with images, they're working with time series data. They may use transformers in terms of trying to do some predictive modeling of a time series, or they're working with spectra. And so it's not all of the science that we're doing is an engagement with a language model. Some of the development in terms of these multimodal approaches to the multimodal universe, I think these have potential going forward. But to give you an example of what do I need to train, I love VS Code. I love it working in its agentic mode. I connect it with various different models. I can get it to write a vast amount of code. It gets to a point where it writes something that doesn't work. And how do I train someone to understand when that's not working, and also how to fix it? And how do I train it someone in terms of it's like doing software engineering. I need to have a real specification. I can't create something just by writing a 2-word prompt or a couple of sentences. That's not going to do something new in science. But if I have a conversation and I learn to have that conversation, I learn how to do that specification, then I'll move much closer to actually making progress in the science. So I think there's places where there are skills that we need to actually train researchers, and less than just going on to the great thing is you can go through a whole corpus of material which the various language models have read and get that summarized to me, but I still have to understand which bits are right and which are wrong. But when I'm actually trying to move do the research with the data that I'm working with, there's a disconnect between working with just with language models.
I know we're over time, but actually to connect these points, I mean, I found that the language models are terrible at telling me the state of research. Like they don't know what papers were good or which were bad, which had a methodology that worked, which one didn't. You know, I have in the areas that I've done research gone and asked it, now explain to me what we know about this topic. And it's just all over the shop. And that's because it's just pulling all the papers together. And I'm really excited to see what you guys come up with. But I think part of what it is training people on judgment. And that's, I mean, this is going to be really hard. I work with this with all my students. They come to me terrible with judgment on like what's a good question and how do you probe deeper to find out what truth is. And that's where I think we're a long way off from not needing to train people up on that.
I'll end with a kind of a semi-optimistic thing that goes back a little bit to the AI slop problem that we started with is that, you know, this idea that you're going to be producing so much more science and you're going to have to wade through all of this and figure it out, you know, kind of obviates the need for better infrastructure for how are we going to, you know, have a digital system that allows us to have all of our publications and to do something scalable that's automated. And similarly, agentic AI, if you want to do the Microsoft Discovery platform to control your thing, you're going to need to build APIs and interfaces and infrastructure so that the AI can control it. And one, I think, really powerful observation is that both of those investments are very useful even without AI. And humans have been advocating for better cyber infrastructure for our publishing systems, better automated workflows and reproducible workflows. And we've had a very, very hard time getting investments in doing these things that basically uniformly people think would be useful for the human approach to doing science. And for whatever reason, everybody's super duper excited about AI, and now everybody's ready to invest in all those things. So we should do it, and I'm all for it, and I'm all for sticking the agentic AI and the automated stuff on there, but we should also recognize that that's a useful investment for humans as well, and that's something I think, you know, that we should embrace and somehow try to communicate to the rest of the people about the value of those kinds of investments. Plumbing. All right.
Okay, with this, let's wrap up this session. I want to reiterate that I really appreciate all the questions that you entered, and they're so thoughtful, and rest assured that Midas will continue facilitating such discussions for actually quite a while, because this is such an important topic for us to figure out together. I want to say a couple of logistic things. Lunch is the same place as yesterday. Poster session is the same place as yesterday. You have until 1 p.m. to vote for your favorite poster, and then please come back at 1:10 to hear the keynotes from Kyle and Brad. With that, please give a round of applause to all the panelists.